Good evening to all. Okay, today we are going to discuss about overview of deep learning approaches, as well as its application. Aspects of deep learning too. Um, this is my presentation outline today. What we are going to discuss. So first of all, we'll go for what is deep learning. Then go for a brief introduction about deep learning. Then we'll go for slowly difference between machine learning and deep learning. In the last discussion, that is the last week, we have discussed about artificial intelligence and machine learning. So I hope you have some fundamental idea about machine learning. Please, you have to recall those concepts what we have discussed. Okay, that will be very much helpful to us to compare this deep learning techniques. Then we'll go for architecture of deep learning, then followed by the importance of artificial neural networks, ANN, and different types of models and the deep learning applications of deep learning. Finally, I'll end up with the references and discussion session. This is my presentation outline what we are going to discuss today. So yes, this is an definition of deep learning. Actually, deep learning is a branch of machine learning. While you are looking this diagram in this right hand side, so you'll get to know about this. That is the origin of deep learning. Actually, the deep learning is that subfield of machine learning as well as the artificial intelligence domain. And that's using machine learning, which is it is completely based on artificial neural networks. You see, as a neural network is going to mimic the human brain, so the deep learning is also a kind of mimic of human brain. Here it is actually representing mimic of the human brain and other things, which is fall under cognitive science, which I already discussed. That is study of human brain and everything. So in you see, in deep learning, we don't need to explicitly program everything. Sir, what you convey here in machine learning aspect, we have to specify our input features explicitly. That means what are the features? Right. So what are the features? Is it my screen is visible? Hello?
No, sir. We don't see that screen.
Right. Right.
Now it is visible, sir.
Thank you. So I told you about there is that main express there is feature of deep learning. That is as a programmer or as an end user, we no need to explicitly specify any features or programming skill in this architecture. That is once you are passing the input to your network, then automatically it will learn by itself and it will come up with the decision. Sir, how it knows about all this image features and everything. Later on, I'll come back to that part. Here, the concept of deep learning is actually not a new. That is an combination of artificial neural networks and various learning techniques. This is a combination that comes into an picture right now. That means even we can say that the old wine in new bottle. That is an just for understanding this conveying this information. Then this is an actually the formal definition of deep learning is neurons. Sir, here we are frequently using the term deep. What it means? So that term deep, which is represent the number of neurons present in that particular architecture that became a deep learning. Sir, then how many neurons are most probably we may expect, or it is present in that network or that neural networks. maybe it's in more than 100, even 500,000. That may vary according to our accuracy expectation, what we are expecting accuracy from that network. Accordingly, we will go for increasing or decreasing the layers and everything. Later on, I'll discuss completely thoroughly about all this information. So the deep learning is otherwise also called it as deep neural learning or deep neural networks, DNN. Okay, deep learning or deep neural learning or deep neural networks. Okay, so I mentioned here it is mimicking that is human brain. You look at this, the left hand side, how our brain is working, that is together. Before I'm going to discuss about the human brain, the unit of our human brain, neurons, right? The unit of our kidney is nephron. Don't confuse with both. Brain means neurons. Sir, how many number of neurons? That means it is approximately billions of neurons. Billions of neurons. Sir. Sir, why we need for a long sleep or some even if you are not properly sleeping, then automatically the problem will rise. You definitely that is going to get affect your digestion system first, then entire body systems. So sleep is eating and sleeping is very much important. If you taken proper food, and if you are sleeping in proper timing, then that sleeping hours will give the refreshment, recharging of our neurons. Even somebody feel that feel tiredness, tired, then if the person will take or some half an hour or even 1 hour rest, that is even bed rest, then automatically he will be very brisk because of this process. So while we are sleeping, our neurons are getting recharged. That's why we need an complete sleep, even 7+ hours. This is my request. Please, participants, you have to take more than 7 hours or 7+ hours sleeping. Come to a topic. Here, look at this diagram. Here, this red color is indicated as an auditory cortex. Actually, this auditory cortex will receive simultaneous input from both our eyes and then ears. Sir, what will happen if the person is visually challenged? So only the persons can recognize sound through their ears. So even in such a case also, this auditory cortex will train by itself and it will make a decision. Right? Sir, how it is functioning based upon the neurons. Later on I'll discuss about this, because even I studied all these concepts when I was doing my higher secondary +2. So after that I completely forgot about biology. Sorry. So later on we'll go for it. You come to the right hand side, you see this visually impaired person is you see how they are recognizing through the over the voice. That is, you see how they can that is, you see images are converted into text, or even it is images are captioned, and that captions are converted into voice. Even here in that below this image here, you see the visually impaired persons are using this echolocation technique. Given it is actually bats are using that technique. Might have seen that bats while it is flying, it never right, hit any of the objects because of this concept. That echo concept, that is that sound is going to hit the objects or obstacles in front of the visually impaired person, and it will replay back to their here. So that kind of concept is going to be used. Right. So then again, that left hand side is that human brain neurons, biological neuron. The right hand side is that imitated artificial neurons. You look at here. Okay. Okay. Yeah, I don't want to go for in depth of this. Okay. So nucleus, that's an okay. You know that control unit of this. Okay, cell body soma. And okay, you see dendrites, which is receiving okay signals from other neurons nearest or adjacent neurons. Axon terminals, which is okay output of this okay neuron. Axon, it is okay actually that is passing the signal from one okay neuron to another neuron. Look at here. So this okay, such a neurons are connected from our okay entire body. Even okay, humanitarian right, sir. How okay these neurons are passing signals? You know, is there any okay relationship between chemistry and this biology? Even okay, do you know how this neurons are passing signals from okay that is from one okay part of our body to okay brain or our okay body part, entire body part to brain. Even okay, for example, just I want to okay ask this okay doubt, that is clarification. Okay, suppose while you are walking, you are okay, toe is okay hitting any stone or okay something okay, or even okay nail is there. Then okay, just it will okay, just okay, pushing your okay toe okay part, and you feel pain. Then okay, immediately the brain is okay making action. Even okay, just you take a pin and okay, just pinch on your okay your thumb or any of your okay palm location or anywhere else, or even okay your hand part, what will happen? So you feel the pain, but you see the distance, your leg part okay, it is far away from okay brain. And even okay okay when compared to your leg, okay hand is near to brain. Or even okay face, just you are pinching something, or sometimes mosquito is biting okay, we feel that okay pain. So you see, anywhere of our body part is quickly transferred the signal from that particular location to brain. So there is no delay. How come this signal transformation is happening in our body? Actually, there is an okay chemical reaction or that chemical compound which is supporting our okay neuron to neuron communication. Na plus Cl minus. I think you know the okay chemical component, no okay name, sorry, sodium chloride. You know this is an okay uh, a normal okay our cooking okay purpose, we people are using this salt. Okay, even okay our parents are okay insisting us okay, if they are okay scolding us or something, they are telling we are not okay responding them, hey add okay more okay much amount of salt to your food. So that's why this is a reason. If something is they are telling, we are not in a position to okay react, it means our neurons are not firing. So that means it is not passing the signals. Then we need a more salt, that is sodium chloride, Na plus Cl minus. Even okay, even so that is our TV programs. Judges are always using this. Your chemistry is not working. Chemistry, this okay, salt only doing all this. Okay, for your understanding purpose. Anyway, I don't want to worry in depth of this okay human brain okay mimicking process. You come to the right hand side. Actually in the right hand side you see that neuron, why it is an okay, it see this axon like kind of terminal. Actually this neuron is okay connected with uh, they are okay adjacent okay dendrites and other things. Excuse me. And each and every input neuron excuse me. Sorry. So each and every neuron has two okay parameters here. One is okay input signal, another one is waiting function. You look at here, the right hand side, you see okay inputs from the other neurons. Okay, so that okay here this okay the cell body is like an okay here yeah, sigmoidal function or some okay firing function, otherwise something, sorry I mentioned directly that function name. It seems there are a lot of functionalities are there, you can set. We have to set that okay threshold value, some firing function for that neuron. Later on I'll tell you about the mathematical functions and other things. You see here, how do we calculate this, okay, threshold value and when it is going to fire this neuron. See here, we are going to set this some threshold value here. So you see y equal to, where y equal to x1 into w1, x2 into w2, and x3 into w3 and its summation. So that function, what it is going to be performed, anything. So w1 into x1, that is summation of this multiplication of weight value and its corresponding input value. Then that final value which is going to be greater than this, okay, threshold value. For example, some, okay, you are fixing this, okay, 5, okay, volt. Then here it is 2 volt, here it is 2 volt, here it is, okay, 2 volt, 2 plus 2 plus 2, 6. So it is greater. Sir, here it is 1 volt, 1 volt, 1 volt, or 0 volt, 1, 1. What will happen? So only 2 volt. So this neuron is, okay, on fire. So this is an, okay, mathematical representation of an artificial neuron. I hope you are very clear about this. Otherwise, okay, later on I'm going to explain in a briefer way. Don't worry. Okay, right. So I told you we'll go for a brief comparison between machine learning and deep learning. That means why we need for deep learning right now. Actually, the machine learning, okay, works on a small amount of data set for accuracy. Because previously, okay, that is even 1 decade back or half of the decade back, okay, we don't have, okay, that much of data, even sensors, cameras, nothing right now. So already I told you in the last, okay, discussion, we are dealing with, okay, plenty, that is that is a flood of data, even you can say big data. So works on large amount of data set is fine, so that deep learning is required. It is dependent on low end machines. So even, okay, our okay, normal desktops are, okay, more than sufficient. Suppose, okay, if you are using, okay, large data set, that means big data. So we need an heavily dependent on high end machines. That means we people are dealing with nowadays GPUs, CUDA. Actually, that is an, okay, software based, okay, platform. Then GPU is a graphic processing unit. Okay, GPU means graphics processing unit. You know about NVIDIA and, okay, other um, that is companies, okay, vendors are providing such an, okay, processes. That means high end machines. Even, okay, we people are okay, dealing about quantum computing soon. So the machines are, okay, much quicker way is going to deal with, okay, heavy that means uh, large data sets. And you here in machine learning divides the task into subtasks, okay, solves them individually and finally combines the results. That means divide and conquer approach. Here solve problem end to end. That means from one end, if you are processing in the input, that, okay, another end it will come up with the results. Here you see takes less time to train. You know the reason why is explicitly the data set is very smaller amount. Here takes longer time to train because of the reason why is the large size of data. Even it is going to, okay, deal with, okay, end to end. Testing time is, okay, may increase because we want to, okay, test all combinations and verify it, but less time to test the data. Once you will get the training, that's all, your model is get ready. Here you look at this, the traditional machine learning. So you see manual feature extraction. For example, sir, how do, okay, we, okay, can you give example how do we okay, represent for example in this, okay, prediction, either the given images, the car, light vehicles or heavy vehicle, even bicycle, even, okay, two-wheeler, truck, etc. So each and every, okay, image or vehicle has, okay, features. For example, car means, you know, okay, the size, that is okay, height of the vehicle, even the wheelbase, headlamps, even mirrors, etc. I hope you are, okay, clear about this. Okay. Deep learning, sir, how this deep learning is going to, you don't need to specify all these features explicitly. What is the base? Okay. Wheel base, how many, okay, headlight, okay, headlamps are there in the, okay, front side, and what is the mirror size, how many, okay, wipers, how many mirrors, okay, that means, okay, that is side mirrors, etc. Automatically it will learn and then come up with the features, low level, medium level, high level features. Okay. I hope you are clear. So why we need to approach deep learning? So this image I'll teach, okay, whatever we are discussed as now. Okay. So as a old crow, he made an hard work. He collected the lot of stones and throw it in the pot. Once the water will come up, and he waited and waited, and he made an such an hard work. But you see the modern crow. Look at this. It's a smart work. Sometimes the smart work is much important than the hard work. Even though sometimes it's a kind of hard work and luck, even you can say. You have an hard work, but without luck, it's very difficult to succeed. So next we'll go for architecture of deep learning. So these are all the various architectures: ANN, back propagation, feed forward, fully connected layer, convolution layer, etc. We'll go for one by one. So the idea is actually, you see, most perception means, already I told you, it's an input processing in the brain, maybe due to one learning algorithm. Even I mentioned about auditory cortex, build learning algorithms that mimic the brain. Even our brain receives a multiple inputs that will combine together, and finally it will come up with a decision. So you see, a learning algorithm that mimic the brain, you see, one learning algorithm. So as one learning algorithm that is going to process multiple number of inputs. Okay, so even machine learning, that is, as a programmer, we are splitting explicitly those features. But in deep learning, environment, we need to make an explicit feature extraction and etc. The same thing what we have discussed. See here, auditory cortex. Even if you are not in the position to hear properly, while you are looking that information, it can grab these details. Even you see, sometimes you are not in a position to count, or you are looking at. So this is an imaging representation of neurons in the in our human brain. How far it is connected with other neurons, you see. So next we will go for artificial neurons. You look at this. I told you. You see this how the neurons we can represent. You see directly it is going to fire. Even whatever it is specified. Here look at this. So there are two inputs and weight values are given here. 1, 1. 0.5. Suppose here x and y both are for example 1, 1. What will happen? Use this equation. So x is 1 and weight also 1, 1 into 1, 1. Then this x2 also 1, so 1 into 1, 1. So 1 plus 1, 2. 2 is greater than 0.5. So that this neuron is going to fire in such a way. Suppose here 1 input equal to 0, no problem. Here 1, you see, 1 into 1, 1. So 1 is greater than 0.5. Suppose sir, both values are 0, then 0. So this a neuron is not going to fire. So you see, look at here, where t is represent threshold. See here, are able to follow? I hope you can understand how this neurons are firing. Look at this, how this functioning. You see this. Sir, what is the diagram it is represent? This is a threshold value. Once it's go up, then this line is indicating that neuron is firing. See here, this is a thresholding value. So x1 into w1, x2 into w2, summation of all the input neurons, and that value is greater than this threshold value. Whatever. So how do we fix this threshold value? That is we can set the value by trial and error basis, or otherwise what are the values like an unfunction or function like that, you can fix it accordingly, or otherwise you can come up with some mathematical notation, then that values etc. You look at here, some sigmoidal function, Gaussian function, or otherwise any of the mathematical firing function, you have to fix it. So I hope researchers can grab all these points. Whoever is doing research or they are okay having an okay thought of okay applying deep learning to their works, please you can note down all this. How do we set the threshold function and other things and etc. So these are the other models, whichever is not mentioned here. Okay, see convolutional layer and the fully connected layer, etc. Okay, yeah. Of field, it is okay. You see this, okay, input values everywhere else, then weight value is going to be calculated and okay, and it is going to be here. Retro propagation, you see feedback, okay, feedback, okay, or propagation, back propagation network, you see here. Input is okay, processed here in this input layer, and the corresponding weight matrix values are there. That is going to be okay processed and okay it is fed forwarded to this okay to okay hidden layers. Again, you see the dotted lines representing that values are going to be again compared to that is fed okay back to that input layers, and it will calculate the differences. You know that okay difference value become an beta, that is error value, then it is going to be fine tuned. I think, okay, that negative feedbacks are much powerful than the positive feedback. So, right. So, this is an, okay, another model, retro, okay, method mechanism. Even, okay, how do we define the, that is neurons or even neural networks for this function and or not? You see here. So weight function is defined, value is okay defined. The unfunction, both are okay high, then output is equal to high. If any one okay line is goes to 0, then it will okay the output also equal to 0. Please you have to recall the and table, or otherwise please you have to refer it. Hope okay you may using okay parallelly internet too. Please you have to refer it. So if I'm okay representing here 1, so 1 into 1, okay, plus 1 into 1, 2, 2 is greater than 1.5. So it will get 5. Sir, any one input equal to 0, then okay, 0 into 1, 0. So 1 into 1, 1. So 0 plus 1, 1. That's it. So 1 is less than 1.5. So this node is not going to, or this neuron is not going to fire. Come to this OR. If any one input is equal to high, then that corresponding output will be high. See 1 1, then okay, see that value is 2. So 2 is greater than 0.5. Suppose so this particular okay line is x1 is okay high. This is x2. Okay, for your understanding, just I'm telling. Sorry. This is okay x1. This is x2. Okay. X2 for your understanding. Suppose this any one value is equal to 1. So 1 into 1. So 1 into 1 plus so 0 into 1. So 1 plus 0. So equal to 1. Okay. So this 1 is greater than 0.5. So this R function is going to work. Here, so you know the not function, inverse. Okay, right. Here that value is okay given. Okay, here 0, 0 into right minus 1, anything into 0, 0. So it will okay equal to then this. Okay, so here it is 0, then it is going to fire okay 1, because value is greater than or equal to something, then it is going to fire. Suppose are 1. Okay, 1 into 1 minus 1. Okay, minus 1 is less than 0. So if it is 1, then it is equal to 0. If it is 0, then it is equal to 1. Are able to follow? I hope you are very clear. Okay. This is the basic structure of artificial neural networks. You see there are three fundamental layers here. Namely, you see input layer, output layer, and the hidden layer. When you are using directly, that means if you are using machine learning kind of concepts, if you go for otherwise neural networks, simply directly neural networks, the number of neurons from the input layer is equal to the number of features from in the data set. Then the output layer neurons, how many number of outputs are suppose my data set has 7 labels, classification I'm going to do. Then 7 neurons, or maybe. So then what about the number of neurons in this hidden layer part? And then sorry, this hidden layer neuron values in between this uh, input layer and output layer. For example, the number of input nodes are 10. The number of output layer equal to 3. Then that is that hidden layer neurons may be in between this. Not less than 3, not greater than 3. 7 9 8 3 4 2 sir no, because in between this values 10 and 3 you have to fix it. Sir, how do we increase or decrease the number of hidden layers? Later on, I'll tell you. So you see, the artificial neural network is actually composed of many artificial neurons that are linked together according to the specific network architecture. Even we are discussed about the architecture: convolutional, fully connected, off field, even retro propagation, feed forward, any mechanism we can for architecture. Okay. Okay. So here, so what is the purpose of this artificial neural networks? You see, controlling the movements of robot. Controlling the movement of a robot, based on the self perception and the other information, visual information. It will either it want to move straight towards straight direction, or left, or its right, and then deciding the category of potential food item, either edible or non-edible in artificial world, and recognizing visual objects, familiar face detection, either it's an bicycle, two-wheeler, car, truck, or heavy vehicles, etc. Even predicting where a moving object goes. Even prediction which direction and angle then that you see want to catch it for that purpose. Okay. Sir, how do we represent this neural networks mathematically? It's very simple. So every layer, please, you have to note down. You see, here this is an input layer, 1 of 1. That means that is the first node in this layer, 1 of 1, 1 of 2, 1 of 3, 1 of 4. So you see here x1 into that weight value. So in that particular layer, weight value 1 of 1, 1 of 2, 1 of 3, 1 of 4, everything. So these values are here is summed. You see here, this is an output of this. You see here, y1, y1 of 1, y1 of 2, y1 of 3, y1 of 4. So all together you see here, 1 2 3 nodes are, it is, you see here all 1 2 3. So how many nodes? 1 2 3. So here only 3, 1 2 only 3 nodes are connected here. Please, you have to be very careful. Here 4 nodes, here also 4 nodes. So even how many nodes are connected here? Accordingly, you have to calculate the function. So this is y of 2 of layer 2, so that you see 2 of 1, 2 of 2, 2 of 3. Then y3, you see y of function of y of 2 comma w1 w3 of 1, only one node is there, so that the same functionalities whatever we have mentioned. So this is an generic mathematical representation of neural networks. I don't want to go for in depth of mathematical representation of neural networks, because you people are feel bored. Please, you can refer any materials. Please, you have to extend further about Mary's mathematical notations. This is for fundamental understanding purpose. I'm giving some important and small feed to you. So W is actually weight of the vector and other things. So you see this energy minimization. That means some of the I told you about retro propagation and other things. You see, we need an appropriate definition of energy for artificial neural network, and having that we can use mathematical optimization technique to find how much how to change the weight of the synaptic connections between the neurons. That is called as error function, the difference. So accordingly, we are going to fine tune our weight value and everything. So energy equal to the measure of task performance error. So I told you. Okay, look at this. How this network is predicting. What is that? Okay, labeled. Okay, either it's a cat or either it's a cat or a dog. If you are passing a dog input, it is going to tell you it's an dog. So you see this, actually the term perceptron is actually single layer neural network, and a multi-layer perceptron is called as neural network. Okay, so even while I'm asking my PG students about perceptron, the person that is the student who did the project under deep learning, under the topic of deep learning, they doesn't know about what is the basic concept of deep learning neural networks. Even they doesn't know perceptron. Just I'm telling my student history. So perceptron is a single layer neural network. Okay, multi-layer perceptron is become a neural network. Okay, the single layer. Okay, how the single layer is doing. Okay, functionality we'll discuss. Here you see this. The perceptron actually is an linear classifier, binary. See here either it will be yes or no. Also it is used in supervised learning like this. Okay, even nowadays people are using deep learning for real-time emotion detection. There are some 7+ emotions, I hope so. Sad, happiness, calm, angry mood, etc. So that that kind of predictions may required that supervised learning that will go for more than this binary classification. You see this perceptron actually consists of 4 parts. Okay, so 1, 2, 3, 4. So you see this input layer. You see input value. This one. This is an layer number 1. Input layer. And then you see weight and bias value. So now you are very clear about what is meant by bias. Then net sum calculation here. This is the third one. There one activation function, that is firing. Okay, here it is going to be happen. So step 1, 2, 3, 4. Sir, what even single neuron that will perform all these 4 important functionalities. So it is going to process the input and multiply with the weight value, whatever it is fixed. Then it is going to sum together and is going to compare with this firing function or activation function. Clear? So whatever we are discussed, it is mentioned here. All inputs x are multiplied with their weights w, and let's call it k. That is w into x is equal to k. So add all the multiplied values and call them weight sum. Okay, if you are suppose 5 input nodes are there, then 5 times you have to sum. Okay, that is you have to sum all 5 values. Sorry, apply the weighted sum to correct the activation function. Look at here. So x1 into w1 plus x2 into w2 plus x3 into w3 plus x4 into w4 plus x5 into w5. Then it is going to compare with this activation function. If it is greater than or equal to this value, then this node is going to fire. Otherwise, it is not going to fire. Okay, if it is 5 neurons are there, then everything is going to be sum. Okay, you see here, if it is equal to greater than x, if it is 0, no. If it is a 1, then it is x is greater than 0. You see this, how it is firing. Even for example, this is an actually an neural network which is going to predict whether the given image is bright or dark. Sir, how? Suppose if all pixels are 1, 1, 1, or even 1, 2, 3, 4. This is a pixel value. 1, 2, 3, 4. You take it in such a way. Okay, so even weight values are equal. So 1 into 0.25, 2 into 0.25, 3 into 0.25, 4 into 0.25. So, so what is the value? Well, please, you have to sum this value. Definitely it will be positive. So if it is positive value, S is greater than minus, minus 0.1. You see this? It's a brighter. Otherwise, sir, all are okay. You see, if it's a pixels are dark, then it's the values are 1, 1 maybe. Okay, right? Dark means 0, 0. So if it's an black and white image. Okay, so you see, okay, we'll go for neural networks. Deep learning is okay primarily about the neural networks, where a network in an interconnected web of nodes and edges. So just you have to recall the diagrammatic representation of that neural network. Actually, neural nets are designed to perform a complex task, placing objects into categories based on few attributes, or even highly structured networks in three kinds of layer, whatever we have discussed already: input layer, output layer. In between input and output layer, we can call it as hidden layer. Each node in the hidden and then output layers has classifier. Please you have to note down. That is, otherwise we can call it as neurons. You look at here. Here there are two hidden layers. How do we fix this hidden layers and its corresponding nodes? So that nodes already I told you how do we fix it. Even in deep learning it's very difficult to identify, because I told you it is not explicitly processing it, our input based features. It will implicitly is going to process. So you have to make some trial and error method. Actually this neural network based modeling and all, it is called it as black box kind of testing. I don't know how many of you are remember about white box and black box testing in software engineering. White box, we know everything, formula, clear cut representation, everything. But in black box we don't know, but we can realize the features like an remote control. While you are pressing that on button, then our devices are switched on and given like a TV or air conditioning system, whatever it is getting switched on. So we know what will happen while you are pressing that button, but internally what they how they, that remote and TV is interacting, and what kind of values or what kind of technology that we really doesn't know. That is called as black box testing. I hope you are clear about it. So here that fixing number of neurons and number of hidden layers all are fall under black box, because only option is trial and error method. Sir, what is meant by trial and error method again? So we have to keep on increasing the number of nodes or the number of layers in between input and output layer. I mean hidden layer. Then we have to keep on verify the accuracy. Is it any changes is happening in that accuracy? If you keep on increasing the accuracy on particular point, it is it is remain constant, then you have to come back on how many hidden layers that is going to make an impact on high accuracy. If you are removing one of the hidden layer, then that accuracy will be getting down. Or if you are adding that and you are more keep on adding that, then you have to stop that particular place where that output become and remain constant. Okay, so likewise we can come up with our model with that number of hidden layers using this trial and error method. I hope you are clear. Okay, sorry. Here there is an live demo. Okay, I will see how this. Is it my screen is visible? See here. Here the number of input neurons are 2 in this input layer. A number of neurons in this hidden layer is 4. Output is 2. That means it is going to make an classification. Even you see here there is lot of functions, firing functions. You see regularization, either L1 and L2 can regularization rate, what how much just I'm going to make it this, either I'm going for classification or regression. That is, regression means prediction. I told you already when we have to go for classification and regression in the last discussion onwards. Okay, so just sir, shall we increase this number of nodes or number of layers as possible? One previously you see this you see this, if I'm increasing 3 hidden layers, right, even I'm going to decrease this. I'm going to increase the number of nodes now 5. Here I'm going to increase or rate number of input layers. See here, if I want, I'm going to increase right. So I've done it everything learning rate just okay. I'm going to make an right epoch. You know what is mean by epoch here? That is number of okay training rounds, iterations. See here, okay, the difference is 0.001. Okay, even you see it will be very closer. There's an error rate here. You see which very much closer. That means they are differentiating this okay orange color and blue color separately. Data items. You see here something maybe okay. See here now you see the curve is okay. I think okay. Now okay it is okay near. Both are okay. You see testing training is similar, so no error. Okay, now it the model is ready. See how many effects? 1,390 even 1,000. Okay, you see 3,500 already. Now you see fine tuned. Clear? I hope you are clear. Okay, understand about this. Okay, neural network how this is functioning. So you can adjust in such a way and come up with this. Okay. So wherever, okay, how many epochs you want to further, just okay, see now it is fine tuned, even testing and training is no loss, everything zero, please you have to stop. Otherwise it will take your, okay, training time, okay, much, okay, large. Okay. The same thing that is a forward, okay, propagation I told you. So if that data is, okay, forwarded from the previous layer to the current layer and current layer to next layer, then it is called it as feed forward. Then it is okay. Then okay. Suppose the input is okay. Output layer is forwarding to the okay n to n minus 1 and the n minus 1 to n minus 2 and then okay so on and then it's finally is reaching with the input layer and it become a feedback mode. Okay, propagation, back propagation network. You see here, back propagation. You see. Passing training net is okay known as back propagation. Okay, already I mentioned. So during the back propagation, weights and bias are tweaked okay slightly until the low cost possible cost is achieved. That is error rate. Okay. Even okay, you see this okay. How far this back propagation was introduced during 1990s. It required a lot of okay labeled training data. Almost all data is unlabeled, but okay, you see here labeled is required. You see the learning time okay did not okay scale well. So you see it was very slow in networks with multiple hidden layers. It got stuck local optima. So there were okay often you see surprisingly good, but there was no okay good theory about this. Okay, how do we fix it and other things. You look at this deep belief network DBN. Look at here how this deep belief network is okay. Also it is okay conceived by okay way of okay Hinton used by Google for their okay work on the image recognition problem. Deep belief network. Actually, this deep belief okay network train 2 layers at a time, and these 2 layers are okay treated like an restricted Boltzmann machines. That means RBM. It's an actually mathematical notation. Please you have to refer it. So I told you each and every network has some mathematical okay model. Even I mentioned some sigmoidal and the Gaussian okay function etc. You can fix it okay according to your data behavior. You can okay train up it. Okay, look at this corresponding diagrammatic okay model. Then okay deep belief network, that is okay deep already I mentioned okay right. What is mean by deep? The number of okay neurons in that particular layer or in that particular network. Actually this DBN is capable for recognizing the inherent patterns in the data. You know about what is mean by inherent, derived from their parents. So it is okay see sophisticated multi-layer feature extractor. Even okay later on we'll go for
Excuse me, sir.
madam.
Sir, some of the participants told that audio, they didn't get audio. Let's be
Madam,
incomplete.
uh,
But
from my
myself is
side,
audible.
maybe from their side, okay, network may be okay, very low. That is the
Okay, okay.
that's why I muted my video too.
Okay,
So this
okay,
is the
sir.
reason. From
Okay.
their side, okay, network is okay, somewhat okay, problem.
Okay, sir. Okay, thank you.
Okay,
Proceed, sir.
okay, madam. So you see here that unique okay aspects of this type of okay net test, that each layer okay ends up okay learning the full input structure whatever it is. We will go for one example later on. after discussion of the slide content. See, layers generally okay learn progressively complex patterns, whatever it is. Sir, how? For facial recognition, you see early layers okay could detect edges and later layers would okay combine them into formal facial features. For example, okay, even that same example I'm going to explain okay later on. For facial recognition, how this deep learning okay network is doing. In okay machine learning, we may go for our okay features. That means what is it okay bright side, even we will go for boundary okay, even spatial based okay, even can I say that term. When my okay we are okay dividing, that is filtering that images even okay, is that what is the technical term, I forgot it right now. um, we are dividing the images actually based upon the region based okay pixel values etc. Edge detection also, edge detection mechanism okay we are going to be, but in our deep learning we are not going to do in such a way. That is going to okay use okay combine together, and it will come up with the okay result. Here you see this deep belief networks learns the hidden okay patterns globally, like a camera okay slowly bringing an image into focus okay like that. Even this okay network requires a set of labels to apply to the resulting patterns okay. Even okay the final step, it is tuned with the supervised learning, then it will okay classify okay is it it's an apple, orange or fruits, vehicle, whatever it is okay. So look at this, the diagrammatic representation of deep learning. A deep neural network actually combines multiple non-linear processing layers. Already I told you, look at this, using simple elements operating in a parallel and inspired by biological neuron or nerve systems. Even you see it consists of okay input, output, and the several hidden layers. The layers are you see interconnected via this okay nodes or neurons, with each hidden layers using the output of the previous layer as its input. You know that is okay feed forwarding approach. Okay, right. So next we'll go for how the deep learning uh, mechanism or deep neural networks are learning. Actually, there are okay two important okay layers. So later on we'll go for it. Here you see this input image. Actually, it's a flower. Then you see here, here convolutional layers are there. Then okay, fully connected layers are there. You see this convolution layers are in between. See the input okay layers okay, and there are two layers here. Even okay, you see this ReLU, ReLU, that is rectified linear unit. That is an abbreviation of ReLU. So most of them are using this stuff, ReLU like that. So that is, it means rectified linear units. It's a pooling, you know, that is for learning, that is going to process this input images from one layer to another layer. Just okay, this layer is going to process basic pixel values and everything. Then that will be processed fed forwarded to the next layer. Then that is going to okay learn the okay low level, medium level, high level features. Then finally all this okay network okay or layer inputs are fed forwarded to this okay network. Then okay that is layer, sorry, fully connected layers to support the classification. Then it will come up with classifier okay process. Either it's a flower, cup, car, or a tree, whatever it is. You see, using okay actually this training data, the network can okay then start to understand the object specific okay features and associate okay them with the corresponding category. Even I mentioned each layer in the network takes it okay takes in the data from the previous layer, transform it and passes okay it on. The network increases just a minute. Okay, how many of you okay facing this okay audio problem? Expand the window to
So now it is okay. They told that it is okay. So in the
okay.
chat box, they told.
Okay. Just I'm getting message. Just a minute.
Oh, no, no. Again, they are telling it is not audible.
Just a
Earlier they said okay. Now they are telling it is not
okay,
audible.
no problem. Just a minute. Okay. Okay.
Can you please check
Going
once
to
again,
okay.
sir?
Just a minute.
Thank you, sir. Is my voice is audible? Can you please share your in your chat box? Is my voice is audible?
Yes, madam, your voice is very clear.
Okay, sir.
Your problem.
Okay, sir.
Okay, right. So here you see here the right hand side how okay this uh, layers are okay processing the input. I told you. So each and every okay set of pixels are going to be processed in the every layer. Say rich boundaries, everything. Okay. Uh, so you come to this okay very good example regarding face okay detection. See here how many layers in between input and okay result layer. You see application okay component you see here. This are actually raw data while okay this deep neural network is processing this okay features. You see low level features. Sir, what is meant by low level features? Okay, features. That means you know our faces okay some boundary even okay suppose okay it's an okay woman face there is an okay difference okay right suppose it's a men face definitely okay they may be an okay having a beard mustache okay even okay short form of okay hair and nowadays okay most of them are okay making funk and then okay lengthy hair. I don't want to go for that. Like this okay we come to this low level features means wherever okay that pixels are okay brighter or similar features okay pixel values brighter okay pixels everything eyebrow side it is dark okay right even lips uh, okay right thank you. Uh, Yes, after reconnecting, okay, you may okay get clearly okay hear my sound voice. That is also that means some technical issue happened from your side. Okay, thank you. So we look at this low level features and then okay middle level features. Again, now you look at this okay eyes, nose, even okay mouth, ears, our okay right then okay jaws everything that is going to be separatedly okay separated that is mid-level features. Look at here nose eyes okay jaws x everything is okay going to be high level our okay face shape even okay round okay shape v shape u some okay representations are there that is high level where okay how much lengthy of our nose okay then okay in between our nose and then okay or okay mouth is there any mustache or no mustache okay beard is covering our face or okay um, right anything okay like that it is going to be identifying everything and processing by itself and fed forwarding to the okay, input of the next layer. You see the network architecture has 10 layers one okay by parameters you see learning okay algorithms 30 okay exaflops and okay 30 GPU days. That means sir what it means GPU means okay graphics already I told you graphic processing unit that will okay that many days it will okay take a time to train this entire layer and this many layers okay much of layers and you see this okay training data set 10 to 100 MB okay images okay identifying this after that okay no problem then directly it will okay a fraction of second it will recognize and it will come up with the result only training it will take time so that is called it as learning. So okay just here it is okay exa means that is you know mega okay right you know we are dealing with the MB GB TB okay now it is exa that much of data it is required to train after that it is getting ready with okay 30 days of okay GPU okay training then okay whatever the image automatically it will okay for this okay deep learning okay implementation purpose you need okay Google okay Colab or otherwise GPU machines maybe an okay two GPU cards or four GPU cards even okay RAM is okay much larger okay criteria which is required because RAM only is dealing all okay such kind of bigger data so you have to be very careful about your system configuration otherwise it doesn't feel okay such kind of okay much quicker performance and other things. So next we'll go for CNN. This is an first one. Previously there are three different types of deep learning techniques: ANN and normal ANN. Next one CNN. Next one is RNN. Okay, so this is an major three types of deep learning. Sorry, ANN with a machine learning, that is an normal thing. Whenever your data set is whenever you are going to you are supposed to use your input as in text, then normal ANN is fine. Okay, text, your input is text, then artificial neural network with a normal learning is fine. Suppose, sir, when you have to go for such kind of that means CNN. If suppose if your inputs are images, objects, or even sound, that is speech recognition, or video, in that case CNN is fine. So based upon your input, you can choose your deep learning models, either ANN, CNN, or RNN. Okay, right. So actually this CNN model, convolutional or CONV net, expansion is CONV net or CNN. So which is introduced by you see Jan Leeken. You see here NYU. It's in Facebook reference. You see this deep supervised neural networks are generally too difficult to train. You see this. Sir, then what shall we do? Then we can go for unsupervised, whatever that topics which are discussed under unsupervised, we can go for it. Even reinforcement learning and thing. But supervised, you see, too difficult to train because it will take all possible combination and huge volume of data. Then you see CNNs have multiple types of layers. First up, which is convolutional layer. So we'll go for brief discussion about what is CNN and its layers, everything. Here you see this multiple layers of multiple types of layers, but fundamental layers are two layers. We'll go for brief discussion about this. Look at this structure, how it is doing all this. See here, every layer that combination is there, that is going to be added with this. You see the series of filters forms a layer one called the convolution layer, and the weights and the biases in the layer determine the effectiveness of the filter process. That's it. So you see each filter represents a single neuron. Each filter it is represent single neuron, each filter. Right, typical neuron is actually you see neurons in a layer activate or fire. That means if that value whatever we fix to that neuron which is greater than or equal to that corresponding neuron input, then it is going to fire. On the other hand, you see the convolution layer neurons search for the patterns through the convolution, that is entire convolution model and other things. You see neurons from different filters search for different patterns, and you see that blue colors are on filter, red colors are on filter, green colors are filters, and you see they'll process the input in a different form. Right. You look at this, the architecture representation of you see CNN network. See this weight values, input feature mapping, fully connected layer, and you see softmax layer. That is these two are helping for classification. These two are helping for feature extraction and everything. You look at this. There are two major categorization of the layers in this convolutional neural network. One is feature detection layer, another one is classification layer. We'll discuss excuse me, we'll discuss each and every layer one by one. We look at this diagrammatic representation of convolutional neural network parallelly. Feature detection part and the classification part. You see here the convolutional neural network is shortly represented as CNN or CONV net. One of the most popular algorithm, CNN for in the viewpoint of images and videos as an input. like other neural networks, actually CNN is composed of an input layer, output layer, and many hidden layers, okay, in between this, okay, two layers. But all are, okay, majorly, okay, categorized into these two types. Feature, okay, feature detection layer. Actually this feature detection layer is, okay, perform actually three types of operation, okay, on the data. One is, okay, convolution, pooling, or, okay, you see, rectified linear unit operation. Sir, what is this? Okay, we'll go for it. What is convolution? Actually it puts the input images through a set of convolutional filters. Actually it's in convolutional filters, that is a mathematical notation, so each of which, okay, activates certain features from the image. So please, you can, okay, go through the mathematical notation of the convolution, okay, filter, how far it is one. Then you see spooling. Pooling, okay, simplifies the output by performing a non-linear downsampling. You know what is mean by sampling. Here, non-linear downsampling, that is why it is called as, okay, pooling. Actually reducing the number of parameters that the network needs to learn about. Okay, that is the purpose of, okay, you know, sampling. Okay, that is the purpose. Then, okay, reloop, that is rectified linear unit, actually allows for fast and more effective and more in mapping the negative values to zero and maintaining the positive values. That means, you know, that is how can I say that, sparse matrix. Even in that sparse matrix, you know, upper triangular matrix, lower triangular matrix, like that. Okay, I don't want to go for in depth of that. So it is going to make all positive values one side, and okay, make it, that means rest of the negative values into zero, because that is not required. So actually these three function, okay, functionalities are done by this feature detection layer using this terms convolutional, okay, layer, that is for, okay, using convolutional filters, and fooling, okay, non-linear, okay, downsampling. Then this ReLU is going to make this, okay, all positive values, okay, together, and then maintaining positive values, and okay, making zero to all negative values. Okay, right? So these three okay, operations are, okay, repeatedly is going to be performed. Okay, how many number of feature detection layers are there here? See this, okay. First convolutional, and okay, followed by reloop, then pooling, convolutional, reloop, pooling, everything. Next, we'll go for classification layer actually. So the classification layer, you know, it is going to, okay, make the, okay, right, labeling of the input, okay, images or data. Actually it's, you see, after, okay, feature detection, then, okay, that, okay, followed by this classification. You look at this, you see, actually the last layer is, okay, fully connected layer, that is a classification. You look at this fully connected and softmax, we will discuss. Um, you see this, the fully connected, okay, layer FC, that outputs a vector of, you see, k dimension, where k is the number of classes that, okay, the network will be, okay, able to predict. For example, even I told you about real, okay, real time emotion detection. Some 7 classes are there, so where k equal to 7 here. Then that is, so that, okay, 7, okay, dimension, that results were going to be, okay, such here. This vector contains the, okay, probabilities for each class of any image being classified. Again, probabilities come into the picture. So the final layer of the CNN architecture use, you see, softmax function, okay, to provide the classification output. Okay, you see, softmax, what label it is according to that, okay, percentage of that matching values, then it is going to map either it's a car or truck, and bicycle or van, etc. Okay, so please, you can, okay, learn about CNN with this, okay, math work, okay, okay, page. See how it is, okay, processing. Even I mentioned about, okay, simple shapes, complex shape, that means, okay, low level, medium level, high level, everything. So okay, this is an example. See how many convolutional, okay, see this, pooling. Again, you see this feature, okay, feature detection, okay, layer 1, 2, 3, and so on. Finally fully connected, okay, classifier, okay, layer, okay, right, layer, you see here. See, so the informations are, okay, available here. So already I told you what is meant by convolution function. So convolution function, please, you can refer this, okay, how they are, okay, performing convolution in MATLAB, okay, you're very much, okay, easier way we can learn with this. Okay, all these functions, filtering, everything. This is for your understanding purpose. Just I'm showing. Okay, right. You see, there is no exact formula for selecting the layers. The best approach is already told you using trial and error method. You see, is to try a few, okay, and see how well the the network is performed, or to use an predict pre-trained network or whatever it is. Okay, I hope you are very clear about this. Okay, next. So as of now, I told you about ANN, when we have to go for ANN, when we have to go for CNN. Next, recurrent neural networks, RNN. Okay, so whenever we are going to dealing with just a minute. Yeah, time series data. Okay, then we are going to dealing with recurrent neural networks. Okay, so whenever we are going to dealing with time series, sir, can you give some example? Weather forecasting data, or every day, we are gathering our pulse rate every hours or every minute. Then our pulse rate may be vary, right? So that is call it as time series based data. So in such case, you may go for recurrent neural network. Okay, right? It is introduced by, you see, brainchild of uh, Georgian and you see Sepp Orchard. So you see RNN actually have a feedback loop where the net's output is fed back into the net along with the next input. So it's an purely you look at here time series. I told you T0, T1, T2, T3. Then you see here that is fed backward even to the previous layers, etc. Even nowadays people are using the term is LSTM. That means long short term memories. This is an the variant of RNN only. Don't think that that is a new technology. It's actually extended version of RNN. It's a memory unit. That's it. Okay, so the extended version of RNN is LSTM. Long short term memory. So actually this is an working procedure of deep learning. First actually the first step is understand the problem and check the feasibility for deep learning. I told you what's your data type, what is your data size. Either you go for classification, prediction, what kind of mathematical model, or what is your data. So data is very much important. So from that you have to understand how your data is behave. So data analysis, it seems half of the collection and data analysis, it seems 70% of your research work will get over. Okay, so after that, so identify the relevant data and prepare prepare set. That's it. So you have to identify relevant data. Okay, that is filtering, feature extraction, etc. Then choose this is second step, data pre-processing, everything. Then third step, choose the deep learning algorithm, either ANN, CNN, RNN, or LSTM, even other versions of deep learning like a GAN, YOLO 5, YOLO 3. Even there are so many models are there. So even I'm going to demonstrate one YOLO 5 model for manual detection. End of this session. Then now so we understand the problem, and we check the feasibility of deep learning right approach. Yes, is there any feasibility? Then identify the relevant data, choose the deep learning approach accordingly, then training the algorithm. That is the fourth step. For this purpose only you need high-end machines, GPU, Google Colab, etc. Once the training is get over, then go for testing the model and its performance. This is the first step. Then fine tune accordingly how many layers you want to increase, how many layers you want to decrease, how many number of neurons you have to incorporate and everything. Okay. Next. This is an deep learning. You see development cycle. So that, okay, left hand side is development and the right hand side is a deployment. You see here, development which already discussed. You see, we have to, okay, identify data set and, okay, analyze, selecting the training data set, okay, select the solver, design that, okay, neural network, train, okay, and then you can go for it. Then deployment, okay, once your model is get ready, then you have to go for, okay, real time, okay, data set. How to process real time data, then you have to store it, and then the model is applied on the data set. Okay, then either it will go for classification, detection, or even segmentation. Okay, dividing that, sir, if my result is not, okay, that much of accuracy, okay, level, then what we can do, then fine tune your model. Okay, then increase or decrease the number of nodes, fine tune your parameters, threshold parameters, everything. Then once again you have to check. Okay, this is the only option to fine tune our method. So these are all the advantages of, okay, deep learning. Okay, best in, okay, class performance on problems is obviously reduces the need for feature engineering. We don't need to manually, okay, okay, right, detect the features. I told you in machine learning we should, okay, go for classification of, okay, features manually, then eliminates unnecessary costs, right? Only training time, okay, you see, okay, it will be an, okay, lengthier, okay, duration, but that is also, okay, possible nowadays based upon our, okay, high-end machines. Even you see identifies defects easily that are difficult to detect, even particularly in painting, okay, painting of cars, or, okay, in manufacturing sectors, there's such kind of deep learnings are, okay, very much, okay, helpful to detecting the defects. Okay, uh, disadvantages, I told you, because human, okay, inventions are has both advantages as well as disadvantages. Only okay, God's creation has advantages, only advantages, no disadvantages. That's the difference between natural and then man-made. Okay, any technology, even the last, okay, presentation, one okay, participant asked about that is regarding this, okay, AI and its machine learning, right, development end. Okay, that means, sir, okay, nowadays I came to know that that's AI, okay, actually mechanism as well as machine learning mechanisms are okay, processing our normal photos and it is make us nude. Yes, even that concept was processed in 2018, it seems. After, okay, that participant asked that question, actually I know that, I hear the news, but I'm not complete about that, completely knowing about this, okay, process. So even that person who invented this, okay, actually uh, is ready to, okay, freely introduce the software only for education and legal purpose, and even soon, okay, we're going to stop this, okay, internet based, okay, supporting of such an, okay, provisions. Even they are asking some, okay, that means undertaking whatever it is, but I haven't, okay, tried that. Actually that software name is deep nude. uh, Actually, here what, okay, sir, if you are expressing everything, okay, others are trying. No, it is not like that. Please, you have to, okay, learn everything and, okay, apply your, okay, knowledge and, okay, your sense. We have an, okay, sixth sense. Accordingly, you have to try, okay, and you know that, okay, there is an ethics you should follow. That's why I'm telling we have to learn everything, no problem. But okay, what we are following, that doesn't matter. Fine. So even, okay, I want to convey one information here. Actually, the technology is like an, okay, a double-sided edged knives. Okay, knife. Sorry. If you are, okay, trying to, okay, hit or okay, kill anyone else in that one direction, another direction, it will kill you. So, this is my humble request. Please use the technology as much as possible or when it is required. Until otherwise, please don't, okay, unnecessarily go for in depth of those technologies. Definitely, it will, okay, um kill your privacy, security, everything. Okay, so this is my suggestion because of okay, with my research experience, okay, even I collected the okay data in such a way, so that time only I wondering, okay, how much okay okay we people are losing our privacy. Okay, so even okay, sorry, come to our topic. These are the disadvantages. um Right. Large amount of data is required. Okay, no problem. Okay, nowadays, okay, we have so many, okay, input devices, IoT components, okay, right? Even IoT to IoE, Internet of Anything. So no issues. Computationally expensive to train. Yes, obviously. Yes. It need an okay high-end configuration machines like a GPUs, quantum computers, supercomputers, etc. No strong theoretical foundation. Yes, I told you how many number of okay neurons and each layers, and how many hidden layers we have to fix it. All are question mark, and requires a good understanding of how to okay model multiple okay modalities with okay traditional tools. That is also okay question mark. So you have to think about okay okay real time situation, and then we have to okay uh, select our okay models. Is it required or not? And okay, these are the okay, major application areas of deep learning. Actually, here I made a boundary. Even okay, there are so many okay applications. Even I'll show the video clips. Even okay, text to voice conversion. Even that voice modulation to which kind of voice modulation you want to be. You can fix it. Even our smartphones are okay. In future, it is going to dominate. I'll show you that everything. Mainly okay, here it is okay healthcare. It is okay predicting okay, okay prediction. Even okay, my student is going to do that work. Previously done on one small coursework that only I'm going to okay show you today. That is manual detection. Even he done in a two-way. Okay, later on I'm going to explain. Then entertainment. Even okay, I don't know how many of you are watching cricket. Even an IPL, even okay other international matches soon. Okay, World Cup also okay is coming. There okay, even okay you people are heard about DRS. Okay, that is okay. Dhoni review system. Actually, it is not Dhoni review system. It's an okay direct review system. So there okay, you might have seen that okay. What's the impact of okay pitching ball? What is the speed of the ball? How much it is spinning? And okay, either it is ball is hitting the bat or okay pad or thigh pad, ground, everything okay, that okay through that okay stem mic and camera, and okay this deep learning application, they are actually predicting all those things. Okay, um so we'll go for it. Even composing the music, even in the last okay session I told you about this okay aspect. No need to worry about musician and composer. Nowadays there is a fight happening with okay composers and okay music composer, musician and lyrics, okay. Nowadays okay, that I don't want to go for that. Then image coloring, right? Robotics, image captioning. Yes, DRSRS, decision review system. Thank you. One participant is okay. And there is a problem. I know that, but I'm right now I'm not in a position to okay come up with that. That is not a Dhoni review system, because Dhoni only used okay as much as possible okay yeah, possible okay reviews. Even he succeeded okay even 90%. So that only just for fun I told you that is an okay okay DRSS, okay, decision, okay, review system, right? And then advertising, okay, sir, how come this advertising? If even if you are looking searching one product, then that product related advertisements are okay, will be displayed by your displayed from your social medias. I don't know how many of you are noticed. Then even okay, this is an one more important okay helpful okay invention with the help of this okay deep learning earthquake prediction. Okay, we'll go for one by one. Okay, see here, deep learning is actually you see reshaping healthcare okay industry by delivering new possibilities to improve the people okay life. See, computer aided, okay, disease detection, analyzing the genomes, discovering the new drugs, uh, even heart, okay, related disease, etc. Even you see here, actually that deep learning, okay, models are performing, okay, early detection of cancer cells, tumors, and improves the, okay, time consuming process of, okay, synthesizing new drugs, and also, okay, invents, okay, sophisticated medical, okay, instruments and everything. So that is an, okay, purpose of, okay, right, deep learning in this, okay, healthcare domain. Entertainment, even I told you about this, even, okay, entertainment, okay, right, you see, uh, even and Netflix, Amazon, filmmaking, even, okay, there are so many, okay, internet-based, okay, providers, right? Providers are, okay, seeking you, that is that, okay, you are, which type of, okay, movies are, right? Even, okay, serials, web series, things you people are like either horror, comedy, sentiment, love, okay, based upon your previous history, they are doing all this. Okay, see here, time of access, history, okay, preferences, etc. And it, okay, even gaming, see here, uh, here the Wimbledon I told, okay, that is, sorry, here it is represented, but I mentioned about, okay, um, cricket. That is an, okay, one of the easy, okay, method to conveying the information. For that purpose only I use that, okay, DRS method in cricket. Then, okay, you see this, okay, uh, music generation and, okay, adding sound to silent movies, everything. Nowadays people are using, okay, these technologies. I don't know how many of you know about, okay, that is Ilayaraja and A.R. Rahman. Ilayaraja is a good composer and A.R. Rahman is a good sound engineer. It's a difference. I don't know do for in-depth of argument about, okay, but, two musicians. I hear, okay, I listen their musics. I love them. Okay, no problem. Right. So here, given I told you about, according to your lips movement, here it is going to identify and come up with the sound, what kind of, okay, sound, okay, the person, okay, generates, etc. And coloring images and videos, you see here that the input is black and white image, and, okay, that it fit, okay, to this neural network. Then you see here at right hand side, sorry for, okay, sorry participants, it's an important call, it's from my mother, sorry. Ah, so this is another, okay, example. Robotics already shown, okay. So many video clips from the previous, okay, okay, talk. You see this, actually deep learning is heavily used, okay, these days in building robots to perform human, okay, like tasks. You see robots are, okay, built to understand the, okay, world around them. Even, okay, you see here, this kind of, okay, devices, see here, like an, okay, imitating of animals, even, okay, other, okay, things. See here, just I'm going to show. Is it okay? My video is, okay, playing from your, okay, side? Hello?
Yes, sir.
Sound is audible? So everything is, okay,
Sound is
based
not
upon the deep
audible,
learning.
sir. Only video is enabled.
Oh, okay, okay, just a minute. Video is enabled. Just a minute. Is it okay right now? Hello?
For me, only video is available. So that's I asked the participants for film. And they're attending.
Music is coming, that is audio background is okay playing or not?
Sound, sir. Only video is
Now,
enabled.
now is it okay? No. Okay, right. Settings, okay, playback.
No, sir. I didn't get any sounds.
I'm not getting anything now.
No, sound is not audible, sir. Only video we are seeing, but sound is not.
Now, now is it okay?
No, sir. No sound. Only our video is enabled.
Okay.
Can you share the entire screen so that we can able to?
Madam, that's why, okay, I stopped my, okay, system, and, okay, I shared my entire screen only.
Yes, sir. Yes, sir.
Then, okay, I'm screen. Yeah, I'm choosing, okay, my entire, okay, yeah. Setting. Okay, everything's fine. Okay, okay, this time, okay, I'll try my best. Is it audible? Okay. Better I can watch it on okay YouTube also, no problem. Taken from this YouTube. Only for okay, for understanding purpose, what kind of okay robots are designed. Okay.
Sorry, sir. You can post that link in the chat box so that audience can be.
Okay. Even okay, somebody okay, share that link too.
Yeah, yeah, sir. Thank you. Sir.
Okay. Right. Okay. Okay, sometimes okay, the player may be a problem. Okay, right? So okay, robotics are okay, making okay dance or movement according to that music, listening and okay, deep learning or okay, supporting that much image okay, captioning. You see here, even okay, my MTech okay student done the work, but haven't okay collected that information from him. He told me okay, sir, I will send. Okay, see here, captioning dog catching a ball. Okay, right? A dog is okay jumping like that. Okay, it is going to okay. You see LSTM is used to okay turn okay labels into coherent okay sentence. That is the purpose of okay LSTM and compared to CNN. Advertising, you see, okay, advertising, deep learning allows optimizing the user experience. You see, okay, it is going to show you which one, okay, which product do you like, and okay, either any discount offer is given, okay, which okay site or which okay vendor is okay giving a concession, more concession like that. Okay, it is going to identify and okay provide you. Okay, right? See, even okay, getting started with the deep learning, you see here with this, okay, AlexNet and other things, okay, either okay, possible to predict all these objects. Even okay, here, okay, this is an example for deep learning, okay, okay, right? How it is, okay, training, what is the accuracy, everything is given. Please, you have to okay, go through it, okay, further, okay, clarifications. See here what tool it is. Okay, MATLAB. Okay, it is providing all this. Okay, supports latest version. Please, you have to go through it. Mm, right. So actually, this is an okay implementation of deep learning. Okay, on manual detection. Actually, this is my okay PhD scholar. Okay, done this okay small work for his okay coursework purpose. Even you see this, okay, look at the pipes, wires, etc. Down underground. That is the purpose of this manhole. These are all the three types of manuals. Okay, normal manual 150 okay centimeters, shallow manual 75 to 90, deep manual more than 150. Here we are dealing with okay this and then okay deep manuals and other things. Actually initially done okay either it is opened or closed. Thereafter I insist him to come up with how much percentage it is opened. That is also he done. For that purpose we used okay deep learning model YOLO 5. Actually, you see, YOLO means okay, you know, Similarly, you look okay. Sorry, you only look once. Uh, Even okay, SBI app, okay, mobile app name is YONO. Instead of that, YOLO. You see this actually CNN based object detectors are actually primarily applicable for this okay recommendation system. That is a model. YOLO it is only for object detection purpose. You see high performance in this object detection okay domain. So actually it divides an image into you see grid system and each grid detects object within itself. You see they can be used for real-time object detections based upon the data streams. Even you see required very few computational resources, but it required GPUs. Otherwise, you are not supposed to feel okay that much of quicker responses everything. Actually, this okay Halo is okay well known for okay its speed, accuracy, and it's okay. It's many applications, even healthcare. Not only this okay manual detection, healthcare, security surveillance, and okay self-driving cars also. In okay 2015 you see uh, ultra okay ultra electrics okay team has been okay, working on improving this model, and thereafter okay you see this okay some 8 years. So there's the latest version is YOLO version 5. There is a difference okay I don't want to go for in depth of okay previous versions and other things. Only I'm going to show you the comparison between previous version and then current version. So that is 4 and 5. Actually, you see, it uses single okay, neural network to process an entire image. The image is divided into okay regions, and okay the algorithm predicts probabilities and bounding boxes for each region. So you see, there are two types of object detection models: two-stage object detection okay detectors and single-stage object detectors. Actually, here the single-stage object detectors like actually this YOLO are composed of three components. You see, backbone, neck, and head. Okay, backbone, neck, and head. Okay, makes an okay dense okay predictions. Look at here, backbone, neck, and then dense prediction. Right, you see this is an actually two stage. Okay, see here, actually the code is available, no problem. I will share this PPT with you. We can use it, but my student is modified that code, and I have done an okay one okay combination. See here that okay the 68 26 86 63. You see this FEN okay 44 49 okay 77. All this okay internal okay neck, these are the layers, backbone, these are the layers, input okay see patches, images, image okay pyramids, whatever it is. Okay, so some okay informations are there. Sir, how do we okay set all this according to your data set? Okay, pixel size you can okay modify it. Sir, shall I use already okay existing that? Okay, you can use it, no problem, but you cannot okay claim that it's your contribution. That is it. So the actually okay there's an architecture of okay, YOLO V okay V5 version 5. Actually the backbone okay can run okay running on GPU or CPU platforms, but the head can be either one stage okay you see here YOLO SSD Retina net for okay dense prediction, or a two stage okay faster RCNN for these okay sparse prediction object detectors. For that okay recent object detectors actually have some layers, that is neck to collect the future mass, but if it's a GPU for better okay performance we may feel. Okay, you see this the YOLO actually in YOLO V4 actually CSPD okay darknet okay 53 is used as a backbone. That is the difference. Actually SPP blocks for increasing okay receptive fields, which okay separate the significant okay features. Actually these are all the okay technical terms. There is no okay reduction for network operation speed. Even okay pan is used for parameter okay aggregation form, different backbone levels. Even YOLO 3 version, so anchor based okay head is used okay for YOLO 5. Actually this is a difference. YOLO 4 is okay introduced new methods of data augmentation okay mosaic and okay self advertisal okay training SAT. mosaic mixtures for 4 okay training images. Self advertisal 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 okay training operates in two okay forward and backward stages. These are the differences. Okay, in the second stage, you see network is trying to detect an object that is okay modified images. This is a major difference between YOLO 4 and YOLO 5. Actually, YOLO 4 is okay released in the okay darknet framework in which it's written in C. In YOLO 5 is based on the okay PyTorch. Okay, it's an actually framework, even library you can say. YOLO 4 actually uses .cfg for configuring configuration. Actually, this okay YOLO 5 uses YAML okay file for configuration. These are differences. Now, this is an architecture of YOLO V5. So there are three okay important components: backbone, neck, and even okay prediction model. You see here. Okay, there's okay combinations. You have to okay make it your own way. And okay, see this input manual okay data set. Backbone actually it is going to perform feature extraction, pre-training okay and okay head to okay predict the classes. Neck collect the feature maps and it's okay between the backbone net and the head okay in between. Head finally it is going to show classification and detection. You look at here. Here it is showing it is okay closed. Here it is actually open, but it is not okay. Okay, as an okay any okay cause it okay it will happen. This is also closed. You see here. This is also closed. Okay thing. Here it is okay. Manual is opened, right? Even it is image also it is showing. This is also closed. You see here closed. Okay. Closed 0.9. Okay, here it is okay closed. Here it is okay. Anything it is open. Okay, right. It is showing. Here it is opened. Here it is open. Closed. This one is closed. This one is open. Open. Closed. Here also it is opened. Open. Okay. 0.9 means it is 90%. Even it is 100%. It is get open. Some okay fine tuning is required. This is also open. This is also open. Okay, open, open. Right? See here. Some of the okay objects you see here. Open, 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 closed, closed. See here, it is closed. Right? So this is an okay. Some of the results based upon the YOLO V5 that okay deep learning models. This is a code just from this Google Drive. It is available. Okay. Sir, what is the purpose of this? Okay, detections and the pattern matching things and all. Yes, I'm going to show you on video clip. Just a minute, I got some message here. Is it okay? Voice is coming. Audio is playing in the background.
No, sir. Only video is audio, sir.
Just a minute, madam. I don't think I'll okay show you the videos. That okay track video. I don't know where it is. Okay. Okay. Anyway. Okay. Okay. I don't know right now where it is available. I have connected those okay, links. Okay. Anyway. So you can see this. Okay. It's an automated okay truck. Last okay. That is a talk I shown about Mercedes Benz car. So identifying the lane objects for that purpose, deep learning is used. It is trained. Okay. So it will take.
Sir, you can share that link in the chat box, sir. Otherwise.
Madam, I don't know where that link is exactly.
Okay, sir.
It's
Okay.
in my folder, just I'm playing. Even I'm not in a position to identify where which folder it is available. I
Okay.
give a link exactly where it is. Just a minute. How to identify that link? Okay. You see here.
Okay.
That, okay. I don't know exactly that links. Okay. So
Okay. Sir,
these are
please share your
various.
screen. Ah,
Oh, okay.
okay.
Just
Okay. Thank you, sir.
okay. So right, these are the various platforms, frameworks regarding deep learning, frameworks and libraries. You see here, R and Python based platforms. Please you can refer this frameworks, platforms, libraries, and these are all the few learn models. Already it is supported by this. Are you used by this AlexNet, Google, LeanNet, PassNet, etc. Yeah. These are all the various resources. Um, MATLAB, AlexNet, right? Even YOLO, etc. So any questions?